So in probability 15C, we're going to look at what are called tree diagrams when we have two events happening, one after another, and we want to figure out the different outcomes that we could have when multiple events take place in probability. So this is called tree examples. So in this first example, we have a spinner that has A, B, and C sections on it, really all equal size. So the probability of each section is going to be the same. Each section is 1/3, 1/3, and 1/3. And so if we spin the spinner, we have a 1 in 3 chance of hitting any of those spaces. And then the second part of this is a coin that we flip, and when we flip the coin, we either get heads or tails. And so you have to think of, the heads, as a half of the time, and the tails as the other half of the time. So heads or tails, two possible outcomes, and an equal chance of getting either one. So if we think about doing each event separately, and then the probability of combinations that we can get and listing outcomes, think of the first event as spinning the spinner. So if you spun the spinner, you could spin an A, a B, or a C. There's 3 outcomes, and each of those outcomes again has the same probability of happening: 1 in 3 of getting A, a 1 in 3 of getting B, and a 1 in 3 of getting C. And so that's your first event right there. And again, this is a tree example, so I'm going to use what's called a tree diagram to keep track of all the different things that could happen. And then after I spun the spinner, then I flipped the coin. And in each case, if I had spun the spinner, got an A, and then flipped the coin, I could have got a heads or a tails with the A. And again, there's a 50-50 chance of getting heads or tails. Half the time heads, half the time tails. Those are the probabilities. If I had spun a B first, again, going to the coin, I could have gotten, again, either a heads or a tails after getting the B. And again, that's a half in each of those. And then if I had spun the spinner and gotten a C, and then flipped the coin, again, I could get a heads or a tails. And half the time heads, half the time tails. And then now this tree diagram allows me to just list all the different possible outcomes. I could have got the A and a heads. I could have gotten an A and the tails, a B and the heads, B and tails, C and heads, or a C and tails. And now there's 6 different outcomes that could have taken place. And if you think about the probabilities of each of those outcomes, it's really a 1 in 6 chance of each happening. And you can see that as the fractions are here. 1/3 times 1/2 is 1/6. You have a 1 in 6 chance of that happening. 1/3 times 1/2 is 1/6. 1/3 times 1/2 is 1/6. 1/3 times, when you have multiple probabilities, you multiply the fractions. 1/3 times 1/2, 1/3 times 1/2, 1/3 times 1/2. Now in this case, all the probabilities are equal probabilities, so you have an equal probability of getting any one of these 6 outcomes. Really, you had 3 different possibilities here and 2 here. 3 times 2 is the 6 possibilities, and each one of those outcomes is one of the 6 possibilities that you could get. So that's example 1. Now in example 2, we have a 4-sided die, tetrahedral die, and a spinner that has just the numbers 1 and 2 on it. So again, we're going to list the outcomes using a tree diagram and determine the probabilities of each outcome. So if we use the 4-sided die first, you could get a 1, a 2, a 3, or a 4. Those are the 4 outcomes on the tetrahedral die. You can't see the back side of this. There's a 3 on one side and a 4 on the underneath. And so those are all your probabilities. And really there's a 1 in 4 chance of getting any one of those outcomes on the 4-sided die. So I write the fractions 1/4 here on each of these arms or branches of the tree to show me that So 1 in 4 chance of getting each of those. And then the next event is the spin the spinner. So when I go to spin the spinner, if I had rolled a 1 first, then I could have spun the spinner and got a 1 or a 2, and here we have a 50-50 chance, 1/2, of getting either of those. And if I had rolled the 2, again I have the same possibilities. And if I had rolled the 3, again I could have gotten a 1 or a 2 on the spinner. And if I had rolled a 4 on the tetrahedral die, could have gotten a 1 or a 2 on this branch as well. So the first event becomes the first set of outcomes. The second event becomes the second set of outcomes. Each branch has to have this second set of outcomes because each one of them could have after the first event. So I'm going to just list all the possible outcomes now. So I could have gotten a 1 and a 1, a 1 and a 2, 2 and a 1, 2 and a 2, this branch a 3 and a 1, this branch a 3 and a 2, 4 and a 1, and a 4 and a 2. So you can see there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Makes sense. 4 on this one, 2 on this one. 4 times 2 is 8. If you look at this, 1/4 times 1/2 is 1/8. 1/4 times, so in each of these cases, each situation is a 1 in 8 chance of happening. Each event in and of itself, there's 4 different possibilities here, and each one of those has 2 possible outcomes with the second event. So 4 times 2 is 8. There's your eighths, and each one of them is one of the possibilities. So those are tree diagrams, very useful when you have multiple events with probability to keep track of all the possible outcomes.